Between 22 degrees north and south of the equator lies the tropical forest of the world, where half of the species diversity lives and thrives every single day. But currently, there's a major structural change happening to tropical forests. The trees are in stiff competition with woody vines. Woody vines are plants that can climb on top of other plants while maintaining a very sound structural stem that's flexible and made out of wood. For the past 20 years, scientists have been reporting that there have been a major significant increase in woody vine abundance in the forests of the Amazon, of Costa Rica, and Panama, putatively due to elevated carbon dioxide in the atmosphere and to fragmentation of the forest due to human activity. But these are not your regular plants. They can choke out trees like a boa constrictor. They can suppress the growth of seedlings nearby. They can shade out the leaves of other plants just by climbing on them and growing on them. And they can create clones of themselves just by branches on the ground. So why are these plants so successful? To address why are woody vines so successful, we have to think about their evolutionary history. The first evidence of a woody vine is from 300 million years ago in the fossil record. And this must have been a good plant strategy because dozens of plant lineages with independent evolutionary histories have figured out ways to evolve species that can climb. And as an evolutionary biologist, we're really interested in traits like this. Traits that have evolved multiple times across the tree of life, because it begs the question of why is this trait so important? It turns out if we look into the internal cellular anatomy of woody vines, they grow and develop differently than trees. All plants have tubes in them that conduct water and nutrients throughout the plant body. And it turns out that woody vines have wider versions of these conducting tubes that can conduct fluids faster and further throughout the growing stem. But if we just take a look back, if we just look with our naked eye at a cross-section between a stem of a tree and a woody vine, we'll start to see the differences. For example, if we look at some of our trees, we'll notice a regular circular stem with rings inside of it. This is considered the regular anatomy of a woody stem. But if we look at a woody vine, we often find the same sort of central stem with annual growth rings or seasonal growth rings, but they also tend to have some peripheral stems attached to it, sort of forming a rope-like morphology. And for my dissertation research, I'm really interested in the development and evolution of this trait and its relation to the woody vine ecological and evolutionary success, because I think that deep down in the cellular anatomy lies the answer to these questions.